We're going to talk about doing a polynomial scale in Measurement and Automation Explorer. We have in Excel created data for our process, which ranges from roughly 0 to 3, with engineering input units of roughly 0 to 5. You can see we have the equation has been defined for us. We will now come over here, go to DACMX Scales, create a new scale. This will be a polynomial. We'll call it my poly. At this point, we need to start putting in the coefficients. So we're going to jump out here and we're going to grab our 0 coefficient. And we're going to go here and paste it in and say OK. We're going to go back, get our next coefficient. Paste it in here. It's very important that you pay attention to, among other things, what the sign of these coefficients are. For instance, this particular one is negative. The last two were both positive. So we're going to paste this one in. And make sure that we make him negative. And tell him OK. And we have one more to go, which is positive, which is x cubed. So you can see here's our cubed function. We're going to paste it in here and say OK. If we look back at our range here, our input voltage range is from 0 to something a little less than 3.5. So we need to go here and modify this to be 3.5. And we can see that our scale here roughly matches what our curve here is. We're going to take our scaled units to engineering units. And there's one more very important step before we can use this. You have to take this guy to reverse and tell it to generate. And we're going to call this from a range of 0 to 3 because 3.5 is just a little bit far. You can say that see that our range here is maybe just off a hair, but not too far. This curve doesn't look particularly good. Let's go back and generate this again and generate him to 3.5. He looks even a little bit worse. This is primarily because what he's doing is calculating a reverse lookup curve, which we don't really even care about anyway. It just has to be there. We're going to save it. We're going to go back to a task that we've already created. We can define this as a polynomial. Again, we make sure our 0 and our max values are set appropriately, and then save it, and it's ready to run.